Hi, my name is Cherokee Drake, and today I'm going to be doing the electron domain geometry interactive presentation. So I'm going to go ahead and admit, off bat, my balloon sizes are not the most consistent, but they're here. Okay, so the important concept here to remember is that, well, I guess I should probably start off with explaining what an electron domain is. So basically, within an atom, there are two main types of valence electrons. First, there are the ones that bond with other electrons from other atoms. So it's like one electron from one atom bonds with an electron from another atom, and that is a set. Now, some electrons just kind of make a pair that's two electrons in the same atom and they bond together. Basically, each of these little pairs of electrons is a domain. But with bonding electrons, they're a little bit different because you can have up to double and triple bonds, and that's just still all one domain because it's attaching itself to the same atom. So basically, a domain is either going to be a pair or a spot where the atom is attached to another atom, if that makes sense. And all of these domains, this is the important thing I mentioned earlier, they're going to repel each other. They're going to try to be as far apart as possible as they can around that central atom. So what I'm going to be working with here today is going to be looking at a hypothetical central atom and representing the electron domains with balloons. Alright. So, our first one is going to consist of two electrons, two valence electrons. So, we're going to pretend that our atom is going to be in the center here. So, these are going to be just like that. They're going to be linear. Completely one line, as far away as possible as they can get. Okay. Now, if we were to have a third electron, it would separate out to be like this. Triagonal planar. They're all kind of two-dimensional still, because that is as far apart as they could possibly get. Right? Alright, this is where it gets a little bit three-dimensional. Here's when we add our fourth electron. I'm going to see if I can tie these together so I don't have to hold them. That was my original thought, was to tie them together, but then I was like, no, that wouldn't be easy because there's got to be an easy way to do this, right? Am I just overlooking it? I'm going to pop one of these, and my cats aren't going to be happy. This has got to be producing great audio, too. Ah! Ha! Look at that. Okay. Linear. Okay, yeah, tying them isn't going to work. Unless I had a string, and I obviously was not prepared enough to buy string. My roommate has some, but I have no idea where he hides it. Okay, we're gonna wing it. Okay. Fourth electron. So these will go down a little bit. Okay, it's kind of, pretend my hand's not in the way, but it's going to be, the bottom is going to be a triagonal pyramid base there, and then one on the top. And this is called a tetrahedral shape. This is what happens when you have four valence electrons. gonna make it work. I love that this video is mostly just me wrestling with these balloons, trying to get them tied together. Okay, look at that. That is a perfect tetrahedral electron structure. Now, we get to add number 5. So basically, this is just going to go on the other side here, the most logical place that it would fit. Okay, so see, it was basically just like our previous structure, except we added another point onto the bottom. We've still got the original 3, the 2 oranges and the red, and the blue one is the 4th one I added on top, and I just added another yellow one on the bottom. Right. Okay. Now our final electron domain that we're going to do is if it was 6 atoms. So basically that middle ring, we just add a 4th one onto it. Alright, so there are 6 electron domains here. So basically this would be something that had like a pair here, a pair here, a pair here, and you know, maybe these other ones it's bonded to other atoms. But yeah, that would be the electron domain geometries.